Hello guys, this is Muhammad Alam and my final project for this class is on Cloudera Manager. In this project, we're going to deploy a cluster running CDH services on a cluster of virtual machines. First, we'll deploy this using the Cloudera Manager's web interface. Then, we'll use Python and the Cloudera Manager's API to deploy the cluster and monitor some of the services inside the cluster. What is Cloudera Manager? It is an end-to-end application provided by Cloudera to manage and deploy Hadoop clusters. It comes with a stack of services such as HBase, Scoop, to name a few of them. Cloudera Manager's API lets us deploy and manage Hadoop clusters and its services programmatically. It is available in Python and Java. The main advantage of it is that it saves considerable amount of time and effort if we are to do the same things like deploying a cluster over and over again. For this, we'll need VMware Workstation running on CentOS and at least 12 GB of memory. This is how we're going to design the cluster. As you can see, it contains 3 nodes, 1 master and 2 slave. The master node runs most of the services and therefore requires higher memory. Thank you for watching this video and please watch the other video for a step-by-step tutorial. Hello guys, in this video I'll demonstrate a step-by-step tutorial on how to deploy a Hadoop cluster using Cloudera Manager first and then by using the Cloudera Manager's API for Python. As you can see, we'll create a cluster using the virtual machines. We'll assign each virtual machine a static IP address. The master will be assigned 192.168.1.101 and the two slaves will get .102 and .103 respectively. The master will be running the server of most of the services and therefore it requires high amount of memory when compared to the two slave nodes. For this tutorial, we'll first create a base CentOS image in VMware Workstation. We'll configure this base image by making necessary changes to the network files. We'll clone this image and create 3 instances of it. Then we'll configure the cloned instances with the static IP address. Finally, we'll move on to set up a cluster using the Cloudera Manager's web user interface. Once we are done with this, we'll delete this cluster and we'll set up the Cloudera Manager's API for Python. Then we'll create another cluster and do the installation of the cluster using the Cloudera Manager's API. Finally, we'll monitor the services in a cluster using the Cloudera Manager's API for Python. Alright then, as you can see, I already created a base image using CentOS and it has 2 GB memory and 45 GB hard disk space and we are using bridged network adapter and it's quite simple and you can see the how to create this in the documentation. I'll go ahead and power it on and we'll show some of the changes we made to the network files. I'll log on to this as root. Now we'll go to the terminal and see some of the changes I made to some of the network files. Firstly, I changed the resolve.config file and here I added the name server as 192.168.1.1 which is our gateway. We'll save this and then we'll visit the etc.sysconfig network file. Here, as you can see, I added these 3 lines. Will enable networking. Will add a host name change.example.com. We'll change this text over here, and for depending upon our node n1, n2, or n3, we'll add it. We'll change the name, and this will remain the same. We'll save this, and then we'll visit some of the network scripts in sysconfig network scripts, and we'll be dealing with the ETH0 adapter. And here we'll provide the device and the static protocol, and here we'll assign the IP address to the device. This is the net mask, and it's simple. And for the when we clone the instances, we'll have to change this IP address. As we've seen before, we'll make the master .101, the two slaves .102 and 103 respectively. Once we have edited these network files, we'll also have to disable SE Linux, and that we'll do by going to the etc directory again, SE Linux, and config. And as you can see this line over here, SE Linux is disabled already, and that's that. And also we need to change the add the host in the etc.host file, and we'll add the 3 hosts, and this is the DNS name of these hosts, and we'll call those n1, n2, and n3 respectively. Now we'll save these files. Next up, we'll have to switch off the IP tables, and that's off. Then we'll restart the network up again using network restart command, and it's up. We'll also create SSH keys, and I have already done that, and you can see the keys in the SSH folder, and we'll create a new key, and that will store the keys in the id_rsa.pub file, and we'll just copy that over to the authorized keys file. You can find how to do this step by step in the report. I've already done it, so I won't show you again, and it's pretty simple. Now finally we'll shut down this instance, and we'll be ready to clone the instance. We'll shut down it using init 0. Alright, then we've shut it down, and now we'll be ready to clone the instances. Right click on the base, manage, clone, next, and we need the current state of the virtual machine. We can create either of these clones, but we'll create a full clone, and we'll name it Hadoop 41. Finish, and this will take a few seconds, not more than that. And alright, then we've cloned one instance, and similarly we'll clone another one. Manage, clone, and we'll name this Hadoop 42. I have Hadoop 43 already configured on another system in a similar way, so we have 2 nodes on this system and 1 more node on another system, and we'll be connecting each other through the IP addresses, as you can see shortly. Finish this, and it'll start the cloning. Alright, then as you can see, this one has clone too, and here it is. We'll power on both of these machines. Once we configure this machine with the IP addresses and everything, we'll also have to change the memory on this. This will be our server, so we'll boost the memory up to 5 GB on this one. And we'll do the same on the other machine. We'll open the terminal. Now we need to edit two files in this one, and it's sysconfig slash network, and we'll change the host name here to n1.example.com. We'll do the same on the other instance. Bring up the terminal. Network file. Oops, that's the wrong one. This will be n2.example.com. Now we'll go back to the main node and I'll go to the network scripts directory in sysconfig. Network scripts. Here we have ifconfig81. We'll create a copy of this and we'll call it it1. It's it0 and it1 are the name of the adapters, and we'll edit this if ifconfig it1. Here we'll change the device to it1 because VMware usually uses it1, and we'll change the IP address to 101. Save this, and now we'll be ready to restart the network, and we'll do that using the network restart, and it's failed. Let me see why. Okay, right, I need to remove the ifconfig 80 file, and now we'll start the network again. And yeah, we're good, and we'll do the same for this node. Here we'll go to the sysconfig network scripts, and we'll copy 0 and change it to 81. Device is 81 and the IP address we'll use is 102. We'll remove the 80 file as we no longer need it. Yes, and we'll try to bring the network up. Slash network restart. Now we'll just perform a ping test on this, and let's see if we are able to communicate to the internet. And yes, we are, and we'll have to communicate to the other two nodes, N2 and the N3, which is on my other computer. And as you can see, these nodes are able to communicate with each other. Alright, then we are on our main node, and we'll install the Cloudera manager, and we'll install the latest version of the Cloudera manager, and we'll fetch the URL, and we'll use curl. We'll go to our root directory, and we'll use curl, and the file is called Cloudera manager installer.bin. So manager installer.bin, and it's downloaded over here. And next we'll have to make it executable. Chmod plus x Cloudera manager installer.bin. Now we'll execute and set up the installer. We'll only need to do it on the master node and not on the other two nodes. Now it's slash Cloudera. This is This is the readme, and you just have to say next and next for the license and accept the license, and then it'll ask for the Oracle license for Java, and we'll accept that too. And this will install some of the packages, and well, once it's done, we'll have to go to the browser and open up port 7180 and perform all the installation. Alright, this installer seems to have run, and it tells us to point our browser to the 7180 port, and see, it was successful. So this will take some time to connect, so we'll pause until then. Alright, then we'll try to use our browser, and with it port, yeah, we're in here, and let's log in. We'll use the Cloudera Express. It's free and it doesn't have the advanced features like Cloudera Navigator support, but for us it's good for us right now. It will install 5.4.0. Okay, we'll have to add the host, and this is a space separated file, and let's see if we can, yeah, the hosts are ready, and we'll use all the default configurations, and this will install Oracle, Oracle's Java development kit, and we don't need this, but if we need this, we can check this too. We don't want to run on the single user mode, so continue. Login as root, and just assign a password. I assigned Cloudera as the password, and no, and this will take quite a bit of time. It usually takes around 15 to 20 minutes for this to happen, so we'll pause until then. Alright then, the installation completed successfully, and we'll hit continue, and it will download selected parcels, and this will take a while as well. It took about 7 minutes for it to download and install the parcels, and we'll continue, and here it's inspecting the host and whether the network is available or not. Everything seems fine, and we'll just hit finish. We'll download the core Hadoop one. We don't need these many services, and we'll just select the defaults for now. Test connection, and then continue. Hit continue, and This will take another 15 to 20 minutes for it to complete. We'll pause the recording until then. Alright then, the cluster setup is over and it took around 15 minutes, as you can see. And yeah, we're good to go. Hit continue and finish. We have some health issues. That's mainly because of lack of memory, I guess. And yeah, under replicated blocks. And if you see here, the hosts, and you can see the memory is very less. It usually takes it works, but it requires at least 8 GB of memory, and the health is bad. So it says that the NTP service did not respond to a request for the clock offset. So we'll just reset the NTP servers on the virtual machine, and we can do that. And I think it's init dot d ntpd stop. Okay, I think it was already stopped, so let's start it. And let's do the same over here. Terminal init.d ntpd1 start. Yep, I'll do the same in the other instance as well. After restarting the NTP daemon, and you can see that the hosts are all in good health, and we do have some warnings. Most of them are the Cloudera management services. We can restart them, and basically we can use the user interface to perform different tasks such as renaming the cluster, restart. The rolling restart is not for the Express edition, it's for the paid licensed one. And basically this is all we can do with it, and it's really easy and it's really simple, and you can monitor the charts and everything. So this is the installation of the cluster using the Cloudera Manager UI, and next up we'll delete this cluster and set up Cloudera Manager API on another three virtual machines. We'll delete these machines and we'll create 3 brand new machines, like just like we created these ones, 4142 and 43 on the other computer. We will create 515 and 5152 53, and we'll configure them in a similar way, and on them we'll install Python Cloudera Manager's Python API, and then using that API we'll deploy a cluster in a very similar way. Now I have configured Hadoop, these three instances, Hadoop 5152 and 53 on my another computer, and it's configured basically the same way as these two as we did in the previous one. And now we'll go ahead and install the Python API for the Cloudera Manager, and before that we need to install pip, and we get the pip from the this is what we need to install. It's an RPM, and then we'll use the yum install to install it off it. So here's the command. It's already downloaded, is it? Okay. Yeah, so it won't come up over here. Now we need to do the yum install. Yum install yes to everything, and it's Python pip. This wouldn't work before if we didn't do this. We didn't download the RPM, so that's why we needed to do it. And as you can see, it's installing, and if we can check the installation once again, yeah, it's there. And now this was the installation for pip. Now we will install install the Cloudera Manager API for Python. So we'll do that using this pip, and we don't need sudo. It's pip install cm API, and it's install it. And let's see if, yeah, as you can see, we have the version 10 of the Cloudera Manager API. And now we'll import some scripts that I have already written, and we'll import it over to this instance, the n1, and we'll execute them. And the first script will be the one where we manually install and set up the cluster. But before that, we need to install the Cloudera Manager .bin file that we did. We need to install it again. And yeah, I have the link here. I just copied it, and it will install it. And now we need to make it executable. Chmod plugs x, and it will be called, yeah. And now we'll need to execute it. So that is dot slash Cloudera manage install, like the last time. Next again, accept the licenses. Yep, there you go. This will run for 5 minutes. It's not a long process. It will run for 5 minutes, and then meanwhile I'll pause and bring the script over to this node. Now while it's doing that, we'll open up another terminal, and we'll start the NTPD daemons if I haven't already done that. The NTPD start. Did I do it? Well, I'll do it again anyway. And here it is. NTPD start. This will avoid the clock offset issues that we were getting in the previous installation. And we'll wait for it to complete, and I'll get back. Alright, then the installation is over, and it's telling us to go to this like the previous time, but we won't do that. We'll run the Python script, and yeah, close this and finish, and yeah, it won't load so soon. And meanwhile, we'll check the script that we have, and it is here. We cluster underscore setup, and here it is. I got much of it is available in the Cloudera Manager APIs, Python documentation, and you can see we're importing some classes. I'll make it large, and yeah, we're importing some classes, and here we mention all the services that we need to install, and here is the host and the port, and this is the list of the hosts. We'll name our cluster as cluster 1, and we'll install this version 5, and these all over here are the hosts for different services like Hive and Reports Manager and PostgreSQL. Incidentally, the Reports Manager runs well if we have MySQL installed already, and it runs into some issues without a database, and PostgreSQL is an embedded database that we're using, so it runs into some issues, but that's fine. If we have a database that we can set up, this will just work just fine, because it dumps its data into MySQL. Here's the username and password that we are specifying, and host username is root, and that's the password, and we won't use the repo. And here's the method that will set up the cluster. So here we'll get the host, and this will get a handle on the instance of the Cloudera Manager, and we're using the version 10, and the password username is already specified somewhere over here. Yeah, so this is all here. We'll get the instance, and we'll begin the trial. Like you remember from the last time, we needed to activate trial license, and this will do it for us. And yeah, the rest of it is here. We create the services, the management service. We call it MGMT2, and everything else is just installation, and we just specify the right parameters inside it. And this is the sleep command, and it's self-explanatory now. Now this one it'll choose the default roles, and we don't need to configure each roles, and it will do it for us. If we need to do that, we can do that too, but it takes a lot of time, and it does provide that functionality though. So if we need to maybe change the roles and do stuff like that, then you don't need the auto assigned roles, you need to assign it yourself. But for now we'll use this, and here's where we're creating the cluster, and we'll add the host, and now we'll get the cluster as cluster one. Now we'll download the parcels, and this really, this gets all the parcels for us, and that it's a very strong functionality. And it will check what is the latest version, and it'll get it for us, and we don't need to download it individually itself. Like with all the version numbers, it will get the latest version. And all this takes a lot of time, but it takes what I noticed was it takes a similar amount of time as with the web UI, but you don't need to click next, and you don't need to wait for it. It'll do it yourself, and you can meanwhile get involved in some other activity that you're doing. So it in that way it saves a lot of time. And here it's really self-explanatory, and it will activate the parcel and distribute it, extract it, like just like we did it in the previous UI installation. We'll do that, and it will inspect the hosts and create the services, and we'll do the auto assigned roles here too. And well, that's pretty much it. This is how the script is, and in the end we'll restart the cluster service, management service will restart it, and we'll execute the first run. It's similar to what we did through the web UI, and maybe we have a few more roles in here than we had in the previous installation. In the previous one, we only installed the core Hadoop, and it didn't have Impala, I guess, and Scoop. So we'll have those here, and we'll save it. And I think we need to make it executable. chmod 77755, I think. Cluster setup Python, and now we'll execute it, and this is gonna take at least 30 minutes. So once it starts running, uh, I will I will pause it, and once it's done, I'll show you that it's done. It's 11:11 in here, so let's see how long it takes. 20 minutes later, and we're more than halfway there, and we've downloaded the parcels and distributed them, and we have inspected the host successfully. And I think next we're downloading these parcels, and oh no, it's already downloaded. So I think we are setting up the services up next. So let's see how long that takes, and we'll be back shortly. Finally, as you can see, it almost took 45 minutes, and it has run, and the cluster is set up. So it's just done. So I hope it's available here. Yeah, this we need to start the management services, so we can restart this here or using a script, but well, we'll check our hosts, and looks like they're okay. As you can see, the script has installed significantly more number of roles here, so the memory is the main problem. But all over the, the installation worked just fine, and we have our cluster ready. And it's also called cluster 1, and here we go. Now next up we will run this script called script1.python, and it basically gets the API and gets the host, and it's very simple and straightforward, and will basically monitor the cluster and the HDFS services and health checks, and will monitor the role name node, the data node, and secondary name node, and all the services running inside the HDFS. So most of them, I mean, I think some of them are not in good health, but this script is something I wrote, and it's fairly self-explanatory, and it's very simple, and anyone with a basic knowledge of Python can write a script like this. And we'll save it, and we'll make it executable. And now we'll execute it, and let's see if it works. Yes, it does work, and here you can see the health summary. We'll go from the beginning, and here's the name of the cluster, and it's called cluster 1, and that's the host name, host ID, and all the services that are running inside the cluster 1. And we're interested in the HDFS service, and similarly we can print out health checks for any of these services, but we only want to deal with HDFS, this one. And its name is this. And it's bad because I think this is the problem. It has under replicated blocks, so yeah, that's a problem. And it's mainly due to the memory and all the issues. So as I said, it requires at least 8 GB in the main node and 4 GBs for the slave node. So it has problem replicating, and it should be solved using the balancer. If the balancer is up, and we'll see here, it's good, but if you run the balancer, it should replicate enough. Or maybe there's a problem with it. Maybe I've replicated the DFS only twice. So this is an example of how we can use the Cloudera Manager API to monitor the health status of HDFS or any service inside the Cloudera Manager cluster. So this is it, folks. I hope you had a good time replicating whatever I have done, and I have all the codes inside the project folder, and I have a detailed explanation of the codes that I've written in the code in the demo. So if there's any problem, you can view the demo file, and you should be able to understand it. Also, I think I skipped the yeah. I also changed the memory to 5 GB, and I didn't capture it in the video, so you can have a look at that too. So thank you guys. Hope you have a good day.